In a minute, I'm going to be showing you how to graph quadratic functions. But in the meantime, go ahead, like, share, and subscribe. We're going to get to the lesson real quick. What's going on, everybody? My name is Dana Harris with Young Gurus Math Tutoring. And once again, I'm back to drop some more math jewels. In this video, I'm going to be talking about graphing a quadratic function. Now, I'm going to do just a few examples, but some things that you want to keep in mind when you're graphing a quadratic function is, first of all, what makes it quadratic is that little exponent of 2. That means that this graph is going to look like a U or a N shape. Now, not a perfect U, not a perfect N, but it's going to be a curve. It's kind of like, think about like the St. Louis Arch, right? Or an upside down version of that. Sometimes they're wider, sometimes they're more narrow, but we're going to go with the basics. Now, one of the most important things also when you're thinking about how this graph is going to look, this leading coefficient, in this case, it's negative x squared. When that leading coefficient is negative, it is going to have a maximum point. When that leading coefficient is positive, it's going to have a minimum point. So you want to have kind of an idea of what the graph is going to look like ahead of time. So there are many ways to graph these, but I'm going to show you just a way that I use. First things first, I talked about the maximum and minimum. And since this has a negative x or a negative 1 for the leading coefficient, it's going to have a minimum. So I'm going to circle that. It's going to have a minimum point. So that means it's going to look like a U shape. Now, the other thing that we need to do when we graph these, we need to first of all start off with the vertex, or actually the axis of symmetry, because quadratic functions are typically symmetrical, and so which means they can be folded from one side over to the other side. So the way that I find the axis of symmetry, it's the x coordinate of the vertex, and so that's negative b over 2a. In this case, b is equal to, let's write it down. B is equal to 6, a is equal to negative 1. So if I have negative b over 2a, what I have is negative 6 over 2 times negative 1, right? So then that simplifies to negative 6 over negative 2, which is positive 3, all right? So the axis of symmetry is at x equals 3. So it's probably, let's see, boom. The axis of symmetry is right here. And we can go all the way up. So that's going to be my axis of symmetry, meaning I can fold this graph right along that line, x equals 3. Now, to find the y coordinate of the vertex, and you can watch the video on that about finding the vertex of a quadratic function, we need to find the function f of negative 3. Now, for the sake of time and because I've already done a lesson on that, check that video out. I'm going to go ahead, and we know that we have our axis of symmetry. And in this case, if we do f of 3, you're going to get, well, let's work with the table of values first, and then we'll talk about that. So when x equals 0, y equals negative 9, right? When x equals 1, y equals, let's see, 1 squared is 1. The opposite of 1 is negative 1. Plus 6, so that's 5. 5 minus 9 is negative 4. So I'm going to have negative 4 here. So boom, I have this order pair 0, negative 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Boom, I have the point 1, negative 4. 1, 2, 3, 4. Boom. When x equals 2, and all I'm doing is I'm plugging these x values into the function. When x equals 2, I'm going to get negative 1. 2 to the second power is 4. Negative 4 plus 12 is 8. 8 minus 9 is negative 1. So boom, we got negative 1. Then if x equals 4, notice this axis of symmetry. Here's a little cheat code for you. So if I have this point 2, negative 1, which I forgot to plot right there, I'm going to have a point the same distance away from the x axis, right? So I know that this point 2, -1 is 1 unit away from the x-axis. So then that means, that tells me, boom, the point 4, it gives me -1. So boom, 4, -1. And then 5, it's going to be the same thing. So boom, 1, 2, we got a point 2 units away from there. So we got a point 2 units away from there as well. All right, so that means you got 5, -4. And then if we go over to 6, we got 6 and same distance. We got a point 1, 2, 3 units away from that axis. 1, 2, 3. So we'll have 6, -9, right? Now, you can actually plug those values into the function, each x value, and get the corresponding y value. Now I have these points. So boom, I'm just going to draw my function. Boom. And that's what this parabola looks like. What we did was we determined whether it had a maximum or minimum point. You don't have to do that first. Then I found the axis of symmetry. From the axis of symmetry, I used that to find the y-coordinate of the vertex. And then I just took my arbitrary values and plugged them in and found the values. And notice these are equidistant from that axis of symmetry, though. 1, 2, 1, 2, 1, 1. 1, 2, 3, 1, 2, 3, because it's symmetric. So that's the first example. We're going to do another example. In this example, we're going to do the same thing, but as you can see, we have a function with the leading coefficient of +1. Now, you can have a leading coefficient of numbers other than 1, but these are just some basic examples. So first thing I want to know, because this leading coefficient is positive, that means this is going to have a minimum value, which means it's shaped like a U. All right. So we want to find the axis of symmetry. How do we find that? -b over 2a. So in this case, b or a is 1. B is -4. So -b over 2a, which is my axis of symmetry. So we say x equals -b over 2a, which is the opposite of -4 over 2 times 1. So my axis of symmetry is 2, right? So x equals 2. So boom, I know this graph is going to fold down that line, x equals 2, right? I know it also has a minimum point. Now, the vertex, when x equals 2, so the axis of symmetry, x equals 2. Now, to find the y-coordinate, so this would be 2, and to find the y-coordinate, I do f of this axis of symmetry. So f of 2, 2 to the second power is 4, minus 4 times 2, so 4 minus 8 is -4, -4 plus 7 is +3. So my vertex is the ordered pair 2, 3. So boom, 1, 2, 1, 2, 3. So that is my vertex. That's the minimum point, right? Now, I'm going to use this table of values. I determine what values I'm going to use in my table based upon the size of the graph that I have. So since I don't have a very large graph, I'm going to use 0, 1, 3, and 4. If I use -1, that value is going to be way off of the chart. I'll show you -1 even though I have it here. It's going to actually be 12, but my graph on my y-coordinate only goes up to 10, so that won't fit. When x equals 0, y is going to be 7. When x equals 1, y is going to be 1 squared is 1 minus 4 is -3. -3 plus 7 is 4. So boom. And then when x equals 3, let me see, 1, 2, 3. 3 squared is 9. Minus 12 is -3. -3 plus 7 is 4. Boom. So I have these ordered pairs, -1, 12. It's not going to fit on this grid, right? But 0, 7 will. So 0, 1, 2, 3, 4, 5, 6, 7. So boom. I have 1, 4. So 1, 1, 2, 3, 4. Boom. I already have 2, 3. And then I have 3, 4. And then I have 4, 7. All right. Boom. And I didn't put 4 0.47 on my table of values initially because, once again, this graph is symmetric. So when I have these values on the left side, notice this 0.14 is 1 unit away from the axis of symmetry. So I know automatically there's another unit that's on the right side, the other side of that axis of symmetry, 1 unit away. Same thing here. This point is 2 units away from the axis of symmetry. So I have another point on this side that's 2 units away from the axis of symmetry. That's why it's symmetric. That's why it's the axis of symmetry. So from there, we can simply draw our graph. Boom. Boom. All right. And that's that. One thing I would do is use a resource such as a calculator to kind of check your graphs. But if you have an idea of what this graph is going to look like before you actually graph it, that's going to help you out. Don't forget to like, share, and subscribe. And remember, Young Gurus Math Tutoring, I got the solution to your math problems.